Hi, everybody. I'm Dr. Emin So from the Department of Anesthesia, Anand Hospital, Tainan City, Taiwan. Today, I'm going to talk about how to keep our working environment a green operating theater. Today, we will talk briefly about the impact of global warming and how health workers like us could help with the greenhouse effect and what will have the anesthesia waste gases effect on the environment. Before starting with our discussion today, I would like to declare that I have no potential or actual conflict of interest in relation to this topic. Here was actually a barrage leak sprang up after a 7.6 magnitude earthquake that hit Taiwan back in 1999. The casualty was 2,000 deaths, 29 missings, and more than 11,000 people wounded. Although we still couldn't predict earthquakes attack, but we as humans can help in preserving the nature and our climate. Next, I will talk briefly about the impact of global warming, how health workers like us could help dealing with the greenhouse effect, and what impact have anesthesia waste gases on our environment.
In order to provide you with more information on how temperature changes lives, now let's watch a short video provided by Sky News.
2 degrees is the target for limiting the global temperature increase, but if greenhouse gas emissions were halted now, temperatures would still rise by up to 1 degree Celsius. 6,000 years ago, temperatures were at this level, and America's Midwest was a desert. The world's food production centres will become barren again. In this future, mountains lose their glaciers and rivers vanish, the Indian subcontinent fighting for survival. A single degree temperature increase could eliminate fresh water from a third of the planet within 85 years. Warming at the poles happens faster than the global average. 40% of Arctic sea ice has disappeared in the last 30 years. While ice reflects heat, oceans absorb it, so as ice melts, the process becomes self-reinforcing. More ocean surface means more heat absorbed, which raises temperatures, making the ice less likely to reform. Mountainous regions are at greater risk of landslides as the permafrost which held them together for thousands of years melts away. Low-lying countries like the Maldives are submerged as sea levels rise, and countries already hit by hurricanes face ever greater storms. At a 2-degree rise, people begin to die in what are now considered normal summers. In 2003, with temperatures 2.3 degrees above average, 52,000 people died across Europe. Plant growth slows down, then stops. They don't absorb carbon dioxide as efficiently, instead emitting it. The extra carbon sees global warming spiral out of control. 125,000 years ago, when temperatures were 2 degrees higher, sea levels were up by 6 meters. Today, that extra water makes up our polar ice, which is melting. By the year 2100, sea levels could rise by a meter, displacing 10% of the world's population. In this 2-degree future, ecosystems across the globe collapse as species migrate and fall out of sync. A third of all life on Earth faces extinction. Scientists say we can still avoid a 2-degree rise if we limit our carbon emissions to no more than 2.9 trillion tonnes. We've already used 1.9 trillion tonnes. We have 1 trillion left to use between now and forever. At the current rate, we'll use it in just 21 years.
In November 2015, Lancet published Health and Climate Change Policy Responses to Protect Public Health. The pictures showed here show an overview of the links between greenhouse gas emissions, climate changes, and health. The green arrows shown in this picture represent greenhouse effects caused by gas emission from our factories or carbon dioxide produced by human activities. The results, as we all know, will be climatic changes like extreme temperatures, ocean acidifications, and air pollutions. These environmental changes would further lead to reduced fishery or agricultural production. The drought or flooding caused by extreme climate will lead to undernutrition, respiratory and cardiovascular diseases. Human activities like mass migrations, violent conflict, or loss of habitats may also lead to other vector-borne diseases or contagious disease like the COVID-19 we are having at present. So what is the direct or indirect effects of climate changes on health and human well-being? Direct changes include storm, drought, flood, and heat waves. Indirect changes consist of water quality, air pollution, and ecological changes. Together with social dynamic problems, it would give rise to mental illness, cardiovascular diseases caused by heat waves, allergies, and respiratory diseases caused by air pollution. The next question is, what is the connection between the global energy system and the health impacts? Here we can see more than 80% of the global energies come from oil, gas, and coal consumption. Substances like chlorofluorocarbons, nitrous oxide, methane, and carbon dioxide that would cause global warming all come from these energy sources. I believe most of us are familiar with this picture, and we sometimes even call ourselves Superman in the OR, because we always have to do so many works together at one time. So if we believe that we are Superman, what can we do in helping dealing with the global warming problem? In the year 2011, Melissa Brothenberg, an anesthesiologist working in Cape Town, South Africa, she wrote an article on the impact of anesthesia gases on our environment. This picture was taken from her article showing two important thermoregulatory layers of the Earth. On the outside is stratosphere, which is ozone-containing, and troposphere on the inside. With the protection of clouds and ozone layers, only half of the energy from the sun is allowed to enter into Earth. Some of this absorbed energy is emitted back into space as infrared radiation. Greenhouse gases present in the troposphere absorbs these infrared radiations and remit it back to Earth. Ozone depleters are broken down by ultraviolet rays in the stratosphere, forming radicals that destroy ozone, allowing more energy to come in. Melissa also used the term global warming potential, which in short is GWP, which describes how many times more powerful the gas is as a heat-trapping gas than the same mass of a reference gas, either carbon dioxide or CFC, over a specific period of time. In Table 1, the GWP for three common anesthetic gases, isoflurane, sevoflurane, and desflurane, were shown. Desflurane has the highest GWP among all three gases and is almost 8 times higher than sevoflurane. Below is the message from Melissa's paper. First, choosing sevoflurane over desflurane as our primary gases will be beneficial as regarding their global warming potential. Second, use low-flow techniques to reduce 80% of the volatile anesthetic usage will be helpful as regarding to the global warming. Third, using 60% nitrous oxide with volatile anesthetic gases would increase the GWP of sevoflurane and isoflurane by 600% and 300% respectively. However, if you are using desflurane, the GWP would reduce by 40%. Fourth, although anesthetic nitrous oxide contribute only 3% of the total nitrous oxide emission in the US back in 2006, replacing nitrous oxide or xenon is still recommended because it would provide better analgesia, rapid inductions, and emergency, neuroprotection, as well as less environmental damage. A study comparing the carbon footprint of 3 different hospitals located in North America and Britain was published in Lancet in 2017. These hospitals are Vancouver General Hospital, University of Minnesota Medical Center, and John Radcliffe Hospitals in the UK. All 3 hospitals have the same amount of beds and employees, and all 3 hospitals offer the same level of medical services. And most important of all, these hospitals lie pretty much on the same latitude, making them having a similar temperature background for comparison. The authors first compared the amount of anesthetic gases used by all three hospitals and then compared them as annual greenhouse gas emissions. As we can see from Table 1, the carbon dioxide equivalent value was highest in University of Minnesota Medical Center. And of particular interest, Radcliffe Hospital did not use desforin at all. And the carbon dioxide equivalent productions all came from isofurin and sevoflurin, making carbon dioxide equivalent value for Radcliffe the lowest at this part. Table 2 compared the heating, cooling, ventilating, lighting, and puck load carbon dioxide equivalent production for these three hospitals. At this part, Radcliffe Hospital was the top carbon dioxide equivalent producer and was near 3 times the production of University of Minnesota Medical Center. The largest carbon dioxide equivalent production came from heating and was almost 4 times that of Vancouver General Hospital. The reason for this high carbon dioxide equivalent production might be due to the design of the hospital, making heat loss to the environment a big issue, especially during the winter hours. Table 3 compared the carbon dioxide equivalent coming from hazardous waste, reusable textiles, food waste, shops, cytotoxic wastes, recycling, domestic wastes, and transportation. At this part, Vancouver General Hospital and John Radish Hospital were similar in the production, leaving University of Minnesota Medical Center being the lowest among all three. When we combined all three scopes together, we found that John Radcliffe Hospital in the UK had the highest total annual greenhouse gas emission among all three hospitals. The emission was 38% more than Vancouver General Hospital. This slide shows the relative contribution of Scope 1, 2, and 3 to the carbon footprint of all three operating theaters. Both Vancouver General Hospitals and University of Minnesota Medical Center carbon footprint came mainly from the anesthetic gas they use. That's foreign, of course. And however, John Radish Hospital have the largest contribution from the energy they use. Carbon footprint from supply chain and the waste were quite similar in all three hospitals. In the United States, healthcare systems generate 8 to 10% of all greenhouse emissions, while in the UK, the national health system is responsible for 25% of public sector emissions. The operating room is a high energy demand facilities showing an average of 3 to 6 times carbon equivalents that of the hospital building. Emissions due to anesthetic gases comprise most of the overall carbon footprint from North American hospitals, accounting for 2,000 tons of carbon dioxide equivalent at each site, which is 10-fold higher than the anesthetic gas emissions from the UK site. As a short summary for the previous study, first, desforin has the advantage of faster induction and emergency than other volatile agents, but it has a GWP 100 of 2540, which is 5 to 18 times more than isofurin and sevoflurin. And second, preferential use of alternative anesthetic agents or strategies like regional anesthesia, like total intravenous anesthesia, has the potential to dramatically reduce theater greenhouse gas emission. Next, how about anesthetic waste gases from our patients? As early as 1956, reports from Lancet have shown bone marrow depressions in patients receiving prolonged nitrous oxide for treatments of tetanus. Later in 1967, the Russians reported abortion cases in female anesthetists, and the incidence was 18 abortions out of 31 pregnancies. These lead to a thorough survey between 1980 to 1984 by the Health and Safe Executive Survey, in which they found high anesthetic waste gases in the recovery room and operating room. 2 more recent studies on anesthetic gas-related abortion were carried out in 1997 and 2003. The earlier one was a meta-analysis showing relative risk of abortions was 1.48. However, later study by Brown in 2003 said that there is no evidence that trace concentrations of waste anesthetic gas could cause adverse health effects to personnel working in environments where scavenging of waste anesthetic gases has been carried out. Early reports on anesthetic gas pollution in the operating room could trace back to 1975 by Bruin et al. The authors collected anesthesia waste gases in 5 different locations around the operating table. These locations could be found as marked by 1, 2, 3, and 4, and 5 on Figure 1. The highest healthy value found without absorbing canisters was located at 2, which is about 10 cm above the patient's forehead. Contaminations of anesthesia room personnel would be more serious for patients using endotracheal tube or mask. The Committee of Occupational Safety requested that working environment must be monitored and the level of exposure must be kept below the enforced occupational exposure limit. Control measures like scavenge and ventilation system must be implemented. The exposed personnel must be placed under the suitable health surveillance, and employees must be informed about possible risk created by such exposure and educated and trained about the precaution which should be taken. The proposed limit of exposure to inhalation anesthetic agents was still under debate. However, the difference was closer when we look at sevoflurane or isoflurane. For sevoflurane, National Institute of Occupational Safety is 0 tolerance, while the National Institution of Health is 2 ppm. When we look at our everyday practice, it is not easy to measure these waste gases in every institute, and the threshold of smelling perception range from more than 3 to less than 100 ppm. If the anesthetics can be smelled, its concentration is well above the maximum recommended level. Study by Kamura and his colleagues found abnormally high concentration of nitrous oxide in 402 obstetric anesthesia cases, in which 42% were by mask ventilation, 19.2% were by disconnected scavenging systems, 12.5% were leakage around the pediatric endotracheal tubes, and 11.5% were due to equipment leakage. This study was published by Carol K. Jung in 2016 in Canadian Journal of Anesthesia. She compared the environmental anesthetic vapor in the post-anesthesia recovery room and the operating room. She found that if we remove the airway device from the patients in the PAR, the waste anesthetic gas would be higher than in the OR and had no difference between sevoflurane or desflurane. These 2 pictures showed exactly how they collect the anesthetic waste gases in the PAR from patients with or without an airway device. Therefore, to give ourselves a green PAR, do try your best to remove the airway device from your patients in the operating room next time. How many of you watching this video know the air exchange condition in your working environment? Actually, the anesthetic waste gases in the previous slides could be corrected if a good air exchange was employed. Recommended air exchange in the OR should be greater than 15 air exchanges per hour, and for the PAR, 6 air exchanges with 2 outdoor air exchanges per hour is mandatory. The Occupational Safety and Health Organizations also recommended air sampling for anesthetic gases in our working environment should be performed on a biannual basis to protect our workers. So finally, for your take-home message, first, stop using nitrous oxide. Second, choose a low GWP gas whenever possible. Third, choose a regional or TIVA if possible. And fourth, for your airway device suggestion, your first choice, you always use an endotracheal tube with cuff. And the second choice, use an uncuffed endotracheal tube with the final choice, an LMA, because it will leak. So thank you again for your attention. We hope that we can work all together, making our world a better place to live in. Thank you.